Hello everyone, in this video we are going to see linked list intersection point. We are given two linked lists which forms a Y shape. In this linked list we have to find an intersection point. You can see in this picture, here one list is there and here one list. Those two lists will collide at here at the intersection point. We have to return this 700 as a result. So how do we solve this problem? This is a quite interesting problem that's been asked many times during the interviews. So watch this carefully and how do we solve this problem? Here I have code snippet to solve this problem. Will be helpful for me to iterate this video. So we separate this two list into individual part. This is how it look like. So with these two lists we'll get how many number of nodes are there. In this one there are 6 nodes and here we have 5 nodes. So what we do is we'll take a bigger length of linked list and make it to equal to the second one. So here you can see here is 6 and this is 5. We have to move one node downwards in order to make it as 5 so that the level will be equal. So then we'll iterate one node at both of the sides so that when the data comes equal, that time you can see this both are equal. So this time we have to return this is as an intersection point. So this is the idea behind this logic in order to solve this problem. So first what we do is we'll get both the numbers count of how many nodes are there in the list 1 and list 2. This kind of Y formation is for us, not for computers. What it comes there and it just go to the next pointers and reaches the end, it stops. So computer does not know it's forming as Y or Z or not. So what we do is we make a count of this one and this one as 5 and 6. Okay, then we have to adjust those numbers. So what we have to do is wherever the node having higher amount of nodes, we have to travel downwards in order to make it as equals to the next list. Here it is 6, it is 5. So in order to make it as 0, we have to travel one node, which means one nodes we have to travel to the next. In case it is a 10, it is 5. You have to travel 5 times to make it as 5. So that's the code. It's written here. First line is to find out the length of this list, first list, and the second line is to find out the length of the second list, this list. And here in between these two while loops is to adjust that next pointers, and this is the place where we travel equally to both of the nodes in order to find out x and y are same. By the time x and y are same, those two, that is the first point, is the called intersection point. So here we have this line for makes the first list count, and the second line is for second list count, and the third section is for when this first list is greater number of nodes when compared to the second one. The third this one is second while loop is for the exactly opposite. When this list 2, suppose it have higher amount of nodes, then this side we have to reduce. That's the reason it is y next and L2. We have to reduce the count also in order to make this as an equal one. L1 and L2, in order to make it as equal, we have to reduce this L1 and L2 in both of these while loops. And once those counts are equals, we have to travel when it's in this position, we have to travel at the same time. So x equal to x dot next and y equal to y dot next, so that where these two nodes are equal, at that time we have to break it. So x not equal to y, until that we have to go. So by the time both are equal, that will be our intersection point. Okay, now we jump back to Visual Studio Code and we'll write the same implementation there and we'll find out the answer for this. Here I have necessary importing statements, and here I have node definition with a necessary fields and a constructor, and below that I have the linked list class which have all of my functions, and inside the int main function I have written x and y. There are two linked lists. So initially the x linked list have elements from 1 to 8, and y linked list having -1 to 4. The next line, what I do is I grab a node in the y linked list, which means here you can see this is the third one, 0 1 2 3. So third one is -4. So I grab this node as m. So m's next will be the 5. So I have given like this so that it will form a y shape. I just print this. We'll see. Here you can see first list having this 1 to 8 and second list having -1 to -4. So from the -4's next I've given as 5, so that I'll form one linked list. So 5 6 7 8 will become common after I linked that node. You can see this I have printed after I linked this the m to n. You can see this 5 6 7 8 are there. So what I get is L1 is in this one also I'll get, and L2 both I'll get, and I'll write the program for this. Okay, now we'll return the pointer. So list node intersection point. It requires two list head node, so list x and list y. I have to count, so what I do is int L1 equals 0 and L2 equals 0. I just write it in a for loop. For here you can give it this in the temp list node temp, and here temp equal to x. We have to until this temp exists, so temp equal to temp dot next, and inside of this you can write L1 plus plus. Same thing for y also, so y, and here it should be L2, and I have to compare either left or right. So first link or second link I have to reduce. So while L1 is greater and L2 is lesser, that time you have to subtract that L1 minus minus, and from the x equal to x dot next. Same thing you have to do for L2, so L2, and here it should be y. Once it's reached equal position, you have to write as while x not equal to y, you have to travel x equals x dot next, and y also y equals y dot next. Ultimately you have to return either x or y, so return x. Okay, here you can just give this as a here itself, but for code clarity I have written like this. Here at the end you have to write cout in y dot intersection point x dot head and y dot head. 2 pointers you have to return dot, here it's data. Here you know this at 5 it should return me as a intersection point. Okay, now we'll write that also, intersection point. Okay, now Yeah, it's printing as intersection point as 5. So this is how you can solve this problem. This is pretty easy solution. There are lots of ways that there to solve this problem. Whether you can just link these two nodes. There are a lot of algorithms are there, but this is a straightforward solution. You can crack this problem as easily. So hope you understood this problem and solution, and thank you for watching this video. We'll meet in the next video.